A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, Instructor for the NPTEL MOOC course Pavement Construction and Technology funded by Ministry of Education, Government of India. Now today's lecture will form a part of our module 2 of this particular course, and it will be on bituminous bound courses and their functions. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, when the term comes bituminous bound layers of flexible pavements or bituminous bound courses of flexible pavements, the thing come into picture is the first term, which is bitumen. Now, what is that bitumen? Bitumen is a binding material which is very widely used in the construction of flexible pavements to construct bounded layers. And this particular is referred, you might be seeing it in terms of a black semi-solid state. This is a black bitumen, how it looks like. There are different sources of bitumen. We will discuss these ones in our upcoming lectures. So, it is a viscoelastic material which is semi-solid at ambient temperatures. When you heat it, it becomes soft and it becomes pourable. So, it looks black in color and known by different names, like we very frequently refer it as bitumen. You will find the term as asphalt also, asphalt cement also, and since it is the costliest component within the flexible pavement, so many a times we refer it as a black gold by pavement engineers also. And it forms a key binding material, since the bounded layers which we are going to make and which will be used in the top courses of flexible pavements, this bitumen is used as the binding material. And this is, and when you use this bitumen along with the aggregates to form a mix, this becomes a bituminous bounded mix, or we can say a bituminous bound course. Now, most of the aggregates have a very good bonding with bitumen. So, this is one additional advantage, that throughout the globe this bitumen has been very popular for use as a binding material with different kinds of aggregates. Now, in a pavement structure, we discussed about the subgrade, the unbound courses. So, when we move up, as this is our natural subgrade, means natural soil or embankment with this is our compacted subgrade. Then we have the granular courses. Then we can have the unbound base courses or bituminous bound courses also, followed by some binder course also, and on the top we will have the wearing course or surface course. Now, as you go on the top, the stresses keeps on increasing because the upper layers will experience higher stresses compared to the lower layers. So, we want our upper layers to be more stronger, and they will be exposed to severe climatic conditions. They will be exposed to higher temperatures. The topmost layer will be exposed to continuous abrasion by the vehicle tires. This will be exposed to directly to the sunlight, will be exposed to water also. So, their exposure to different climatic conditions, and as well as the stresses which are going to take place because of the vehicle loads will be higher in the upper courses. So, that is why we want these upper courses to be more stronger and resilient. So, while moving upward in the pavement crust from the subgrade, the intensity of stress increases, necessitating stronger and more resilient pavement layers to effectively withstand the applied loads. This is important. And here comes the role of the bitumen. It gives us a binding material. It is a binding material which gives us a mix which is flexible, which is water. Bitumen alone have been used in various other applications. It has been used for making structures, or as a water repellent structures also, or as a waterproofing material also. So, when this combination of aggregate along with the bitumen gives you a good strength, mix with a very good strength, which has a good cohesion also, and which is able to sustain the different environmental and loading conditions also. So that's why these bituminous bound courses are important, plays a very important role in the structure integrity also, as well as in the functional requirements of a flexible pavement. The bituminous bound courses are mainly used in flexible pavement, and the three layers in which they are typically used forms over the top course, which we call it as surface course or wearing course, an intermediate course, which is your bituminous binder course, and a bituminous base course. So bituminous base course is the one which comes over your granular courses, and then a bituminous binder course is the one which comes between your existing bituminous layer and your top surface course. So this is bituminous binder course is your an intermediate bituminous layers. So the bituminous binder course is the intermediate layer between the bituminous base and the bituminous surface. So these are the three layers. All these three layers are constructed using bitumen as the binding material. Now you can see these are the unbound layers, granular layers. Then here there are two layers. These are the two layers which have the bitumen as the binding material. Now what are the main functions of these bituminous bound layers? As I mentioned, these are the layers which are going to bear the maximum stresses on the top. So they should be able to provide sufficient structure strength and durability, since they will be exposed to different environmental, temperature, climatic conditions, different loading conditions also, loading conditions, different axle loads, different speed, vehicles moving at different speeds. So all these will be encountered or will be, the upper layers will be subjected to higher variations compared to the lower layers. So they need to provide a sufficient structure strength and durability to the pavement to withstand heavy traffic loads under varying environmental conditions. Other aspect, they need to be strong enough so that they distribute the load, they are able to distribute the load over a wider area, specifically so that the stress intensity on the lower granular and unbound layers gets reduced and remains within their load bearing capacity of ultimately when it comes to the soil subgrade. And when it is used as the wearing course, top course, as I said, this will be subjected to continuous movement of traffic. So we want a smooth surface for that means a good riding quality, and it should be able to provide a good skid resistance. Otherwise this kind of thing should not be there, that when you apply a brake your vehicle skids on the surface. You don't want this kind, because this kind of thing will make your movement over the surface unsafe. The other part is, since there will be continuous rubbing which will be taking place between the surface and the vehicle tire, so the surface will get abraded, so it should be resistant enough to bear this abrasion. And nowadays another requirement which is posed at many locations, especially in urban sections, that the noise which is generated by the movement of these vehicles over the surface should also be low. So these bituminous bound courses which are used on the surface course should produce low traffic, the tire pavement interaction noise, we can call it in that terms. In addition to this one, it should act as a waterproof barrier. This should be a dense enough or a layer which is impermeable, so that water doesn't enter into the underlying layers, because that damages the structure integrity or the strength of the underlying layers. So these are some important functions which are to be served by these bituminous bound courses, which are typically used as surface course, binder course, and as a base course. Now what are those different type of mixes which are used in these courses? When we start with the base courses, the two mixes which are quite prevalent, their use is quite prevalent in as a bituminous base course is a bituminous macadam and a dense bituminous macadam. We will see what is a dense bituminous macadam in the upcoming slides, what is a bituminous macadam. Then the one which is very frequently used is bituminous binder course is your dense bituminous macadam. So you can see dense bituminous macadam is used in both base courses as well as binder courses. Now when it comes to the top course, your surface course, there are a good option of mixes available. Now these mixes serves various different kind of purposes and are suitable for different situations. We will discuss some of the important mixes in the upcoming slides. The first one you can see, it's a bituminous concrete mix. Second is a stone matrix asphalt. Third one is a gap graded mix with rubberized bitumen. This is a specific type of bitumen. Then we have semi-dense bituminous concrete which is there. Then we have open graded friction coarse mix which is there. Mastic asphalt which is there, premix carpet is there, mix seal surfacing are there, surface. These are certain mixes which are there, which are typically used for low volume roads. These premix carpet, mix seal surfacing, surface dressing, or some renewal coats are there. At the most popular, you can see bituminous concrete is a very popular one, stone matrix asphalt is a very popular one mix which is especially used for national highways and state highways or heavy duty pavements like expressways. Now this table can give you a more idea about it. This is a table taken from IRC 37 2018 which says that if you have a design traffic greater than 50 MSA under surface course, you should prefer to use stone matrix asphalt or a gap graded mix with a rubberized bitumen or a bituminous concrete mix. So this you can see when higher traffic is there, these three kind of mixes are advised to be used as a wearing course. When the traffic is again lesser in magnitude, that is in the range of 20 to 50 MSA, again these three mixes are prescribed, but there will be a difference in the binder type which has been used. So like what has been prescribed, there may be a slight difference in the binder types, and depending upon the category of road, even if the traffic is less but then also it forms a national highway, then you will prefer to go for these high type of surface courses. Now when the traffic is less 20 MSA, then it says you can go for bituminous concrete also, semi-dense bituminous concrete also, premix carpet is also, mix seal surfacing also, surface dressing. This is these three mixes which have been shown here. And along with it, for these different level of traffics, it mentions what can be used in your base courses and binder courses. As I said, these base and binder courses, here it says DBM can be used both as base and binder courses. For this traffic level also it can be used for base and binder courses, but when it comes to very low traffic, here the other term which is mentioned is bituminous macadam. For rest of the cases, we have seen most of the time dense bituminous macadam is referred as a base and binder courses. Bituminous macadam is referred as a binder course only when the traffic is less than 20 MSA. So we mentioned that we have different categories of mixes falling under the base courses requirement, under the binder course requirement and the wearing course requirement. One classification normally for these mixes, bituminous bound mixes, comes in terms of their denseness, and that is what, and the denseness is on the basis of the aggregate gradation which is selected. Now you can see here three different type of gradations have been shown, and specifically the first one is your dense graded bituminous mixes, second is your gap graded bituminous mixes, and third is your open graded bituminous mixes. Now all are bituminous bound mixes, but they are having different characteristics in terms of their denseness. Now you can see the dense graded bituminous mixes, you will find here in this case one bigger aggregate particles will be packed with smaller aggregate particles, voids of smaller will be further packed by the more smaller particles. So you have the distribution of different sizes. So if I show the distribution, aggregate distribution or aggregate size distribution for a dense graded one, it goes in similar fashion. So it is somewhere like a S curve which you might have studied in case of soil characterization also. So this distribution gives me a distribution of sizes in all ranges, and here if I put the classification in terms of coarse aggregates which are greater than 2.36 mm size in pavement engineering or bituminous mixes, the classification is in terms of 2.36. It says coarse aggregates are the one which are greater than 2.36 mm size, fine aggregates are the one which falls in the range of 2.36 to 0.075 mm, or this can be called as 75 micron, and whatever passing through this 75 micron will be your filler. So, in a dense graded mix, typically you have around 50% of coarse aggregate, 43 or 45% of it, and 5 to 8% of your filler. When it comes to gap graded one, some typical sizes are removed out of it. Here you can see this particular one, within this range there is not significant change in the percentage passing. So, that is why these sizes are missing in this gradation. So, this is what here, because a major shear is with 80% of coarse aggregate, then fine aggregate and filler, because ultimately they also need to be made dense. So, whatever voids gets created needs to be filled up with finer materials, but we are missing certain sizes and keeping these lower fractions or filler more, so that ultimately that also becomes dense, but not with intermediate sizes, by keeping the lower sizes. So, this and specific purpose of doing it is to more of coarse aggregates, to bring more contact points, especially in these coarse aggregates. So, these are load carrying skeletons, I will say. So, I want to have more of coarse aggregates and more contact points between this one. So, that is what the gap graded mix is. When it comes open graded, here my specific purpose is to generate more amount of air voids. Now, in this case you can see this is a open graded one. So, the open graded one, this blue one is my open graded one. The entire major part is lying in this particular range only. So, it is a uniform size of aggregate. You can see 92.5 or 93% of coarse aggregate only, and remaining is only around 7 to 8%. So, that shows that this is more of a uniform aggregate gradation. A lot of voids will be there in this kind of mix. So, our discussion, this helps us knowing the gradation, we can make mixes, combination of mixes having different distribution of aggregates within it. So, we can have dense graded one, we can have gap graded one, and we can have open graded one. So, let us just go with the different kind of mixes. The one which, as I mentioned, for the low traffic less than 20 MSA, a mix bituminous macadam, which is referred for use as a base course mix. What is that particular mix? So, bituminous macadam is typically referred as an open graded mixes, as I mentioned, because you will find the aggregate gradation have more words compared to what is there for a dense graded one. And that is why it is typically, and as you go down, granular courses will have more air words compared to what you have in the binder course or your bituminous bound base courses. And there is no specific design, it is a sort of recipe mix which is to be followed, and the design is to be as per IRC 27/2009. Now, if I look once the mix is prepared, what typically the range of air voids we expect. If once the compacted mix is there in the field, then a dense bituminous macadam mix or a dense bituminous concrete mix may have air voids in the range of 3 to 5%. On the other hand, the bituminous macadam mix can have voids in the range of 20 to 25%, which is quite high. So, this high range of air voids makes these mixes permeable to water. Now, when you are using these permeable bituminous macadam as a binder course, then you have to be cautious enough, because as mentioned during the drainage layer also, if some water enters into through the surface or through the sides because of any reason, then this particular layer, which will be your bituminous macadam layer, which is quite porous because it has 20 to 25% of air voids, will hold water. Now, in that case, I should have some proper measures on the sides under the shoulders to drain this water away from this one, as I did in the case of drainage layer. So, similarly, it has to be taken care for the bituminous macadam base course also when you are using this particular course in the flexible. If not, then chances are there that the water gets trapped in the bituminous macadam and it damages your structure integrity of the. So, like you do for the drainage layer, top drainage layer, extend the provision for the removal of water from the bituminous macadam course also. Gradations, as mentioned, there is a gradations have been specified for bituminous macadam also. What gradations can be preferably used, what sizes can be. Is an open graded, there is a potential that it may trap water or moisture within the pavement system. So it mentions, it is mentioned in the MRT's specifications also. Therefore, adjacent layers should have proper drainage quality to prevent the moisture induced damage to the beam. So this needs to be, but this needs to be properly taken care in the field while construction of bituminous macadam. Now here you can see why a recipe mix is given. Already it mentions that okay, you prepare a mix at this binder content level, and this particular second gradation. Now these two gradations are specifying two different sizes, especially the nominal maximum aggregate size NMAS. One is for 19 mm, second is for 80 mm. So normally we want a layer thickness to be at least twice to 3 times of the NMAS. So that's why if NMAS is 19, I will prefer to use a layer which is around say 60 mm of thickness. So this gives me, and there it says if you have this aggregate gradation, it is preferable to use 3. So already it is given that you go with this one, but this is for most of the common specific gravity of aggregates we encounter. If the aggregates specific gravity, that is around 2.75, if they have a high specific gravity, then you can reduce the binder content. And if you have some colder regions where you want to be more specifically where the temperatures, most of the temperatures are below 20 degree, 10 degree centigrade, you may have to increase your binder content also. So that's why these mixes are called as recipe mixes. Now when it comes to dense graded bituminous mixes, which are used again for higher traffics, it is used as a binder course also, it is used as a base course also. Now we'll to get an idea how it looks like, we can have these two images. Here you can see there are various sizes of aggregate particles, coarser, smaller, more smaller, more smaller, then fine dust is there, only aggregate particles are shown. You can see this matrix, you have coarser aggregate particles, this is a coarser particle, finer, more finer. Then some of the fines get embedded into your bitumen also. So it forms a bitumen matrix also, or we call it as a filler bitumen mastic also in CAT. So it's a matrix which gets formed with the filler, fine aggregate and binder along with your this course. So dense graded aggregate structures are perhaps the most commonly used gradation to construct the structure of primarily low transferring bituminous bound courses. This is the most preferred gradation for construction of flexible pavements. These mixes consist of aggregate particles of various sizes progressively packed into each other. So this gradation is important to achieve a density, the desired level of density or the desired level of impermeability to water when it is made with the bitumen. And how this low transfer ability is developed, because you develop this matrix where you will have stone to stone, there will be friction between these stones, there will be a cohesive matrix which will be developed, and the aggregate particles gets interlocked within each other. Mixes like binder and wearing courses are laid over previously laid bituminous binder course is as the previously laid bituminous binder course is the intermediate layer. So what is there? If I have a granular course, this one over that particular one, the first part will be my binder course. So I will not, sorry, the first part will be my base course, which is a bituminous base course. So over granular course, then my bituminous binder course will come. And then my wearing course or surface course will come. All are having a bitumen as the binding material. So base courses will come over granular courses. Binder courses doesn't come directly over granular courses. Binder courses requires a existing bituminous course to be constructed over it. Use of dense graded bituminous mix in construction of flexible pavements is quite common throughout the globe. It's not that it is in India, throughout the globe this is very commonly used. And IRC codal guidelines IRC 111 2009 suggest 3 types of mixes under this particular category. One is dense bituminous macadam, second is semi dense bituminous concrete, and third is your bituminous concrete, and they specifically give guidelines where you can use DBM as base and binder courses. So one layer can be considered as now depending upon the gradation which is used, I will show you later on. One gradation can form as a binder base course, second gradation may become your the binder course of DBM. So DBM mixes will have different aggregate gradations depending upon the sizes of aggregates which are allowed for in that particular course. Then you have semi-dense bituminous concrete, which is used preferably as a wearing course, and bituminous concrete which is also used as, and in the top if I look like the, when we go from the base courses to binder courses and wearing courses, the size typically gets reduced. You make your mixes more and more finer, so you get a more smooth surface on the top and a more dense surface on the top. So, and this is a normal conception. Depending upon the mix types, it may slightly vary, but how if you have a larger aggregate size DBM, it looks like this manner. If you have a slightly smaller aggregate sizes, this is a semi-dense bituminous concrete, and this is a bituminous concrete. So from the top visual visuality of these three mixes, you can get an idea. Here you are seeing bigger aggregate particles, here you are seeing still some less finer aggregate particles than bituminous concrete, a highly dense surface is there. Now as I mentioned, dense bituminous macadam, the IRC 111 suggests two gradations for it. One is your DBM 1, second is DBM 2. What these two are, they differ in terms of the NMS, that is the nominal maximum aggregate size which can be used in this particular one. Now this is a 1 inch aggregate size. If I use a 1 inch aggregate size, I can construct a layer which has to be from 50 to 75 mm. And if I am using a 1.5 inch aggregate size as an NMS, I have to have a layer thickness from 75 to 100. These are, so depending upon NMS, and then NMS a gradation ranges, how the gradation has to vary with respect to the different sieve sizes are again given here. Now again this will, when we will be coming up to the design of bituminous mixes, we will again come to this particular aspect. Now if I need to have 3 courses, this is if I have a granular course over which this is my, I will call it as a wet mix macadam, which is my granular base course, over which I want to have bituminous base course. So I will prefer, in that case I will prefer to use a DBM 1 here, but the layer thickness in that case should be in the range of 75 to 100. I will prefer a finer one, can be as a DBM 2 for that case. So this will become my binder course, and the layer thickness will be in the range of. Now this layer thickness are decided when we look for the pavement design of your pavement crust, but I can assume these ones. I can assume, say I will assume 80 mm thickness for my bituminous base course. I will take as say 70 mm thickness for my bituminous binder course, and then I need to provide a wearing course which may be your BC or which may be your SMA also. So this is how I can pick up these gradations and construct my base courses, binder courses and wearing courses. Now in this one also, it is very important to smartly pick up the gradations which are more usable. See, in the previous case we have mentioned for DBM 2 gradations 1 and 2nd, and there was in one case the aggregate was having a sizes of 1.5 inch as NMS, and the again this was having 1 inch. That is, so when I am talking about this particular one, I have to be cautious enough what challenges may be there if I am using DBM 1 and what challenges may be there if I am using DBM 2. Normally it has been experienced when you use these higher sizes aggregates having or a gradation with higher NMS, the segregation is more. Segregation means you will find some the honeycombing sort of a structure will be there. The coarse aggregates are getting accumulated with lesser fines compared to the other portion of the surface. So, this is a segregated surface. This happens more when you have larger aggregate sizes. Now, this kind of difference in the aggregate gradation may make your mix more permeable to water compared to what you are expecting overall from the mix. So, if a chance is given to you, you can prefer to use DBM2 as your base course, and then followed whatever gradations you have, you can go for some other mix as your binder course, and then followed by the wearing course. That I will show you when I will come to the next slide with bituminous concrete. Now, here how this is important, if I see how NMS is affecting, what the maximum aggregate sizes is affecting, if that is increased for the same mix, if one mix is having an NMS of say 12 mm and the other mix is having an NMS of 25 mm, the chances for the same level of air void content, the chances may be there that the permeability, the mix may be significantly higher, have higher permeability because of this segregation related issues. So, even a good number of mixes are given to you, but the engineer has to be smart enough to pick up what, because it is similar to what products are available in the market. You have to be smart enough to pick up which is the right one, which gives you the maximum benefits. Now, as I mentioned, if I choose a dense bituminous DBM2, because this mix is having a 1 inch or 25 mm as my NMS compared to the earlier one, the other one DBM1, which was having a 1.5 inches. Now, if this forms the base layer, then what will be my binder layer? So, I have two gradations for bituminous concrete also, which is used as a wearing course. Now, here you can see there are two gradations. Again, these two gradations vary in terms of their NMS. One is 19 NMS and 13.2. There in that particular case of DBM, it was 37.5 and 25 mm NMS was there. So, if I have these two options, then instead of it, what I picked up this 1 inch 1 NMS 1 for my base course. Now, within these particular two gradations which are available, I will prefer this one with 19 mm NMS as my binder course. So, I will make this as my binder course, and on the top I will have this one as my wearing course. So, and here it says that the layer thickness can be around of 50 mm and this can be of 25 to 40 mm. So, now I can have a DBM 2 which can be of a layer thickness say around 60, followed by a BC 1 which can be a layer thickness of 50, and followed by a BC 2 as a wearing course of layer thickness 40. So, this makes my three combinations. So, we need to be smart enough to pick up which gradation of these different mixes can be used in different layers as bituminous bound course, bituminous binder course and bituminous wearing courses. Then the other layer, as I mentioned, the semi-dense bituminous concrete, mainly referred used as a bearing course for low volume roads or where the traffic is less, or on urban sections as a renewal coat. Because you can see, and there in semi-dense bituminous concrete also they have given two gradations, SDBC1, SD. So, you have options. You have to be smart enough which option and which combination you have to pick up at different layers. Again, it says if the NMS is 13 mm, then you can go around 3 times of it, then the layer thickness should be at least 40 mm. If this is 9, so the layer thickness should be around 25 mm. So, 2.5 to 3 times of the NMS should be your layer thickness. Here when it comes again for 19, the layer thickness of BC as discussed earlier should be in this particular range. When it comes to 13.2, it should be 25 to 40 mm. Now, so semi-dense bituminous concrete, the important difference, the word itself signifies that it is not as dense as your bituminous concrete. It is a semi-dense bituminous concrete. Now, you have to be smart enough where there are challenges related to the waterlogging problems are there, or heavy rainfall regions are there, where the traffic is very high. You should prefer to go for bituminous concrete mixes compared to semi-dense bituminous concrete mixes, because you will see the fines, you will find certain fines are missing in the, or missing means the stress on this particular one is comparatively less compared to, and you can see if I pick up any gradation which is say 13.2 for semi-dense bituminous concrete and 13.2 for bituminous concrete, you can see if 1.18 is picked up, my requirement is 15 to 30% of this material should be finer than this 1.18 mm, whereas in case of bituminous concrete it says it should be from 34 to 48% should be finer than this. So, I am making it more finer, more denser. So, bituminous concrete 2 with the same NMAS can give you a more dense surface compared to the semi-dense bituminous concrete one. Now, the other important mix, which is your stone matrix asphalt, which is quite popular specifically because of its special characteristics. As I said, this falls under the category of gap graded one. Gap graded, I am picking or I am removing specific sizes out of the aggregate gradation to bring more contact between the bigger aggregate particles. So, more stone on stone contact within the bigger aggregate particle sizes, which I want to have a better load transfer between this. So, stone matrix asphalt, that is why, since I will intentionally try to skip some peculiar sizes. So, it will be called as a gap graded bituminous mix and this one, because I want to have more contact between bigger aggregate sizes or bigger aggregate particles, so that the load transfer can be good enough, or the load transfer mechanism is strong enough to take higher axle loads. So, this gives me a higher resistance towards rutting, and in these kind of mixes, since to hold the aggregate particles we use higher filler material and higher binder content is there. So, a matrix which is formed which have a good cohesive strength, and because of higher binder content it is more resistance towards the damages caused by environment or by the sunlight. So, we call them the aging resistance is also very high. So, this gives you a mix which is good enough, flexible enough, stiff enough, and having a good aging resistance also, and it forms a popular choice and specifically recommended when traffic is more than 50 MSA by IRC 37. So, as I mentioned earlier, they have a good share of, specifically higher share of coarse aggregate particles compared to otherwise dense graded were having a much bigger share of fine aggregates. So, here the fine aggregate particles are removed, that means the gap gradation is created to have more contact between coarser aggregate particles. So, this is how it can look like. You can see how the bigger aggregate particles, so more contact points between the bigger aggregate particles are developed for a better load transfer to make this mix more stronger compared to your conventional dense graded bituminous concrete mixes. So, it gives us a stone to stone contact. This is what is expected. Coarse aggregate particles are in contact with each other due to the reduced fine aggregate proportions, and a binder rich matrix. I will put more fine, I will make the binder rich matrix with the fines and higher binder content, and many a times we stabilize them using some polymers or some fibers also. So, we make them these mixes more durable and stronger, especially for creating long lasting pavements or for expressways or national highways having very high traffic, more than 100 MSA or 150 MSA. So, very popular among national highways and expressways in that case. So, now again there are gradations which have been specified for SMA also. So, you can preferably go for one SMA gradation as a binder course and the other one as a wearing course, but SMAs are not used as your base courses. So, they are used as a binder course. The two gradations, if you want to work with those two gradations, you can use one of them with higher NMAS as a binder course and the other one with a smaller NMAS as your your wearing course. You can see these two gradations again, NMS of 13, NMS of 19. So, if I am given, I will prefer, I can make use what, I can put DBM2 as my binder course, the one which is with 1 inch or 25 mm NMS. I will use this particular one as a binder course. Then I will put an SMA, this gradation I will call it say 2 with his 19 mm NMS, and on the top I will put this SMA which is having 13 mm NMS. So, this will be my wearing course, this will be my binder course, and this will be my base course. So, this combination you have to smartly picked up to understand how the things work out, and they specifically this because of the gap graded aggregate gradation, these mixes even provide you high skid resistance compared to the other conventional dense graded mixes. So, this is again an important advantages. Because of this gap gradation, the coarser aggregate gradation, you get a better skid resistance compared to what you get with the dense graded bituminous concrete mixes. So, it is very important to pick up these different type of dense graded mixes or gap graded mixes for use in your bituminous bound courses. We will continue with this discussion in our next lecture. Thank you.